Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 75 from the Smith Organic Chemistry textbook. This problem tells us that reaction of butanenitrile with methylmagnesium bromide followed by treatment with aqueous acid forms compound G. And so we're told that compound G has a molecular ion at M to Z equals 86. And then we're given some IR and NMR data for G as well. And we're asked to come up with a structure for G. Okay, and so with an M to Z of 86, there's an oxygen in here, so that's going to account for 16. And so that leaves us with 70. And so I'm going to say that this is C5. So that's 5 carbons. So that's 60 mass units. H10, which would put us at 70 mass units. And then 1 oxygen. So that's going to get us all the way to 86. And so actually, I'm going to rewrite that in green. So C5, H10, O. And so I'll write everything that I'm doing in green to distinguish it. The stuff that I write in black is stuff that the problem will have given us. Okay, so C5H10O is a possible formula here. We have an IR peak at 1721. So that's consistent with a carbonyl, so carbon double bond oxygen. Okay, and so we can calculate an HDI for this formula, C5H10O. So that's going to be 2 times 5 plus 2 minus 10. So that comes out to 2, all of that over 2. So we have an HDI of 1. And so this carbonyl makes sense. That would account for our 1 degree of unsaturation. So unfortunately, our NMR integrations are given to us in integration units. So we need to convert them to number of hydrogens, number of protons. And so the way that we do that is we add them all up. So we have 25 plus 17 plus 24 plus 17 for a total of 83. So we have 83 integration units in total. We have 10 hydrogens in our formula. And so we divide 83 by 10. And so 8.3 integration units is going to be equal to 1 hydrogen. So then we just need to divide each of the individual units by 8.3. So 25 divided by 8.3 is roughly 3. 24 divided by 8.3 is also roughly 3. And then 17 divided by 8.3 is roughly 2. Okay, and so now we can fill those numbers in for our NMR signals. So our triplet at 0.9 ppm is going to be 3 hydrogens. Our sextet at 1.6 ppm is going to be 2 hydrogens. The 2.1 ppm singlet is going to be 3 hydrogens. And the 2.4 ppm triplet is going to be 2 hydrogens. Okay, and so now that we know that information, we can get to work a little easier on solving the structure here. Okay, so we have a triplet at 0.9 ppm with an integration of 3. This is almost certainly a methyl group. We have a sextet at 1.6 ppm with an integration of 2. So this is probably a methylene group. 2.1 ppm singlet with an integration of 3. This is probably another methyl group with no neighbors since it's a singlet. And then a 2.4 ppm triplet with an integration of 2. This is probably another methylene group. Okay, so when we take all of this information together, we have 2 methylene groups, 2 methyl groups, 1 more carbon to account for that isn't accounted for in those proton NMR signals, and a carbonyl. And so let's start with the carbonyl, I suppose. So here's our carbonyl. And I'm actually going to put our second methyl group, so our third signal, to one side of the carbonyl. And that makes sense because it's pretty deshielded. It's at 2.1 ppm. So that's an acceptable chemical shift for a methyl group alpha to a carbonyl, alpha to a ketone. So I think that makes sense. And then when we look at the splitting of our last signal, the 2.4 ppm triplet that integrates to 2. So that is going to be a methylene group next to another methylene group. So we have this right here, 2 methylenes, and then we'll put our other methyl group right here. And so let me just point out which signal is which. So this methyl group, oops, wrong methyl group. This methyl group is going to be right here. So our sextet signal that we have is going to be these 2 protons because they're split by both the methyl group to their one side and by the other methylene group to their other side. So that's why that's a sextet. And then our other methyl group is going to be right here, alpha to the carbonyl, which is why it's so far downfield. And then lastly, our other methylene group is going to be these 2 protons. Okay, and so that's the correct structure for G. And that's the answer to chapter 20, problem number 75.